Hello, this is John Baugh again, and this week we're going to go over the lesson 3, and lesson 3 consists of control structures, which is a foundational topic in C++. Primarily we will focus on the repetition control structures, which are also known as iterative control structures, as well as branching control structures, which is also known as selection control. The chapter will help you establish a solid foundation to write significantly more complex programs. It will allow you to program software that makes decisions and can either go one way or the other, or can also repeat a series of actions. Before we begin, I assume that you've read and are comfortable with the topics from lessons 1 and 2. And specifically, you should know how to create a project in Visual Studio 2010. You should know how to declare and define variables, use the arithmetic operators, and retrieve user input. So before we begin, you should read over the section 3.1 so that you are a little bit familiar with logical operators, relational operators. The logic that we deal with has to do with the truth of statements. We use what's called Boolean algebra, and we can compare and combine these statements, even very complex ones, to determine truth or falsity of an expression. Many of the operators, the relational operators, you're probably familiar with already. From mathematics, you're familiar with greater than or equal to, less than or equal to, and equal to, and also not equal to. But in some scenarios, we might have two or more logical statements that we want to combine. And we use the logical operators to do this. We have logical and, logical or, and logical not. Logical and logical or are both binary logical operators, meaning they take two operands. Read over that section so that you're familiar with what they do, but essentially logical and combines in such a way that if both A and B are true, then the whole statement, the whole compound statement, returns true, false otherwise. Now, or is kind of the opposite of that. It only returns false if both of its operands are false. A logical not is a unary operator, and it just reverses the truth of a statement. So if one statement's true and you say not whatever that statement is, it will turn it to false, and if it's false, it will return it to true. So in section 3.2, we start with selection control structures. So I have Visual Studio fired up here, and I'm going to create a new project. I'm going to make sure I'm under Visual C++, and I'm going to make sure that I have Win32 console application. What I'm going to do here is call it lesson 3, examples. I'm going to change it to an empty project under application settings and verify that it's console application, just like I've done all along, and finish. Then once I have my solution and project created, I'm going to go to source files, add new item. I'm going to ensure that C++ file, CPP file, is selected. I'm just going to call it main.cpp. I'm going to write the skeleton just like I always have. And there you have it. So what we're going to do now is we're going to deal with the if single selection structure first. The first example that I do involves input of weight. So I might say int weight equals 0. I say cout, enter your weight, and then the user enters the weight. We learned about input and output last lesson, so if you're not familiar with cout and cin and declaring variables, then you need to review the last two lessons that I created. Then I say, welcome to the gym. And then if their weight is greater than 300, we want to tell them, you might want to consider a personal trainer. Okay, this is obviously just an example. You could have the condition be something else, but here we see we're using the greater than operator, which is a relational operator because it's relating the weight to the value 300 by saying if this is greater than. And that's either what goes in the if statement's header is either true or false. If the weight that they enter is true, that it's greater than 300, explicitly greater than 300, notice this does not, if they entered 300, it would not get to this if statement. But if it is 301 or greater, then it would enter this block of code and print this out. So let's give it a couple runs. Just going to build that. Ensure that it succeeds, which it does. Start it without debugging, and then let's put 150. It'll just say welcome to the gym, and then the program terminates. If I run it again, and I enter 305, it says welcome to the gym, and it prints out you might want to consider a personal trainer. This is because of the statement we had on the if section. Now let's change this program slightly to accommodate an if-else double selection structure. Let's modify it so that it becomes an if-else structure. Now in this case what we're going to do is if their weight is anything 300 or less, we're going to say please feel free to get a drink at the smoothie bar. Alright, so in this case we have one or the other which is going to execute. So if the weight is greater than 300, it will say you might want to consider a personal trainer. So if it's 301, 305, 400, 500, 600, it'll go in here, this section. But otherwise, if it's 300 or less, it will go into this section. That's what else means. If it's this statement, do this. Otherwise, do this. So let's run the program again and see what happens. In this case, I'm going to enter 175 as the weight. Say, welcome to the gym. Please feel free to get a drink at the smoothie bar. If I run it again, I will enter 405, and it will say, welcome to the gym. You might want to consider a personal trainer. So we see in this case, it's like a switch. It's one or the other, right? Now you can chain these as well. So let's say we'll do else if weight is greater than 400. We might tell them that please consult a doctor before starting an exercise routine. Then we can also have an else, which is a default. We'll say cout, please feel free to get a drink from the smoothie bar. Okay, so now we have three possibilities. We could look at this as this. So this is if else, and then this whole section is within this else section right here. And it's separate, but the way it's normally written is chained in this way. You have if, then else if, then else. We're going to build it. Start without debugging. If they enter 150, it'll say, welcome to the gym. Please feel free to get a drink. And then what we're going to do is try it with a weight that is greater than 300 but not greater than 400, so let's say 350. Say, welcome to the gym, you might want to consider a personal trainer. And then we're going to try something that's a little heavier, so 405, it's going to say, welcome to the gym, you might consider a personal trainer. Now what happened? There seems to be something wrong. Well, what happened in this situation, since you're chaining it with an else, out of this chain of 3, this one will never be executed because it is connected in this chain of 3. As soon as one true statement is found, it will break out of this entire section of if statements. Now, if we want both of these to execute, then we have to delete the else and move it down. So it could look, it'll be 2 separate sections. This would be a single if statement up here, and this right here would be a separate one. So let's build this and run it. And then let's try 405. So in this case it says, welcome to the gym, you might want to consider a personal trainer, and please consult a doctor before starting an exercise routine. So it works the way we expect now. Okay, now as another example of a selection structure, let's try the switch multiple selection structure. Now in this case, we're going to use a character and enter a grade. So let's say char grade, and then see out what is the student's grade. Then the user enters the grade. Then we're going to perform a switch on the grade. Okay, so this is a switch statement, beginning of the switch statement. This is the variable that will be used in the switch cases. So if I say case A, in other words, if the grade is A, I'm going to say, you're doing excellent. And then I have to break to prevent what we call cascading. We don't want it to have to cascade, which I explain in the document more thoroughly. I'm going to say, you're doing well. If the user enters a B, then if the user enters a C, I'm going to say you need to get a tutor. If the user has a D, I'm going to say you really need to get a tutor. All right. Actually, on the C in the document, I put you should study more, but we should say you should study more, or consider getting a tutor. We'll do that. That's fine. We're flexible here, right? Okay. Now, default, we're going to put you're failing the course. Frowny face, because it's a really professional program. We have to use emoticons, right? Anyway, once we're done with this, then we know that it could be an A, a B, a C, a D, and we'll assume that the user will enter the correct types of letters, and we succeeded, as we see down here. So let's go to debug, start without debugging. If I enter an A, it'll say you're doing excellent. If I enter a B, say you're doing well. And let's try a D. You need to get a tutor. And if they enter an F, you're failing the course. Okay. Now, I also go through how you can do what's called fall-through. For example, if the user enters a lowercase letter for each of these letters, then we have to find a way to take that into consideration. So, because right now, if we run the program and the user enters a lowercase a thinking, oh, well, the student's grade's an A, it'll say you're failing the course. Well, that's not right. That seems to be a problem, right? So what we're going to do is for each of the corresponding capital letters, right under the first statement, we're doing what's called fall through, because if this is true, it'll go through regardless, and then also if this one's true. So it'll consider both of these cases. As long as it doesn't reach a break statement, it will fall through. Okay, so we put a lowercase b there, a lowercase c here, and a lowercase d here. Now if I build it and run the program, we'll see that if I enter a lowercase a, it'll now say you're doing excellent, and take the others into consideration as well. So that's useful. That's very useful. So those are the selection control structures. So you've got if, single selection control structure, you've got the if-else double selection control structure, and then you've got the switch multiple selection control structure. Next, what we're going to do, I will delete all this, and we're going to go into repetition control structures. In this section, I go over, section 3.3, I go over the while, do while, and for iterative control structures or repetition control structures. This type of control structure causes some sort of code to repeat multiple times. The first type of control structure I'd like to go over is the while loop, or the while repetition control structure. This is a simple example. So if I say int count equals 0, you have to count the number of times we're going through the loop for this particular example. And then I'm going to say cout count equals, and then write out count. Okay, then count plus plus. Okay, now let's look at the different sections. This first part right here, where it says count less than 10, that is the condition that's being tested. Just like in an if statement, it's testing this. As long as this is true. Now, with an if statement, it would just say, is this true or not? If it is, I'll do this once and then break out. If it's not, I'll skip over this code. With a while statement, or any kind of count control statement, any kind of repetition structure, it will test this condition, and then it will perform these statements inside the loop, and then it will repeat. Now notice we have to increment the variable count so that it starts at 0, remember, so we have to move towards the termination. This is called the continuation statement. So as long as the count is less than 10, it will keep repeating the statements inside the loop. Now the problem is that if I commented out this, or deleted the count plus plus, or forgot to put the count increment moving towards this statement, then this would enter what we call an infinite loop. That means it doesn't necessarily mean it would actually go on for infinity. I mean, your computer would die eventually, or the memory would get exhausted. Something would happen where it wouldn't go on for actual infinity, but theoretically it goes on for infinity. There's nothing to stop it until you force quit the program. Okay, so let's run this though. Let's see what it does. Alright, so when we run this, it does what we expect. Since the count is initialized to 0, we say cout count equals 0, and then count equals 1, 2, all the way up to 9. When the count gets to 10, i.e. at the end of this, it's 9 and then it becomes 10, the condition is checked and it says, is 10 less than 10? That statement is false. Now 10 is equal to 10, so if this said count less than or equal to 10, it would continue. But since 10 is not less than 10, it breaks out of the loop, goes here, and then hits the return statement, and the program terminates. That's why it ends after 9. Another example that I show in the book that I'm writing is, what if we have we use a different control structure down here called the do while loop. Now the syntax is somewhat different, and you'll notice, oops, that should be cout. If I say count equals count, I'm putting the exact same code in here, count plus plus. Before I enter this do loop, I could set the count back to 0. I should do that. but I want to show you something. So if we do that, you'll note that they do the exact same thing, 0 through 9, and then 0 through 9. So what's the difference? Well, let's look at what happens if I set this to 10, and then delete this reset of the variable right there. And just to make it a little more clear here, I'm going to put an indel there. Not that it'll matter in this example, but you'll see. So what should happen? Even before we execute it, let's ask ourselves what should happen. So we initialize the count to 10, then we test the condition while count less than 10. Is 10 less than 10? No, so it should never enter this loop. Now what about here? Well, the do while loop is guaranteed to execute at least once because it does a post-loop check instead of a pre-loop check. So it goes into the loop, the body of the loop first, then checks. So even though count is 10, it will print out the count, then check the condition. All right, so let's build this program. We note that it succeeds. We go to debug, start without debugging, and you'll notice the only thing that prints is count equals 10. That's coming from this do while loop here. Okay, so we've learned about the 3 of the iterative control structures, if, else, and switch, and we've learned about 2 of the repetition structures. So now let's learn the 3rd repetition structure, which is the for loop. This one is perfect for count-controlled loops. So in this case, it starts at 0. In the header, we declare the variable in the header, then a semicolon, then we have the test condition here, and then we increment the variable to move towards the termination of the test condition. So everything's compact in the top. So it's a little more efficient, not efficient, but a little more clean in some ways than the while loop is for count-controlled loops. So let's say I is equal to I. Okay, very simple. We build it, and we run it. Oops, that's not right. I hate when that happens. Okay, you'll probably do it several times too. Or hit Control F5 and you won't have to worry about it. But you go to debug, start without debugging, and we have 0 through 9 again. Okay, so that's how a for loop functions. All right, let's see what else we need to cover here. Okay, well that's pretty much it. I would recommend going through the material that I provided with the chapter. You will also learn about the sentinel-controlled loops, and or also known as flag-controlled loops, in which a loop is controlled by the input. So I'm going to leave that as an exercise for you, the user, and remember to visit my website at profjpbaugh.com. Again, it's profjpbaugh.com. Feel free to email me if you have any questions or if you have any ideas for topics you'd like to see, even if they're more advanced than this basic stuff I'm going over right now. That's fine. I will try to accommodate you as time permits. Again, profjpbaugh.com, and you have a great day, and hopefully we'll get to another lesson soon. Thank you, and have a wonderful time.